Hello, guys. We're continuing with the Aztec interdisciplinary material today. We've completed the sections of science, social science, as well as English or literature and writing. So right now we're starting with. We did a little bit of math earlier, but officially this is the beginning of the mathematics section. So before we start, there's some random notes I just want to go over. If we get cut off, I'm sorry. I'll try to fix the situation. And so the notes, some points. A prime number is a natural number greater than 1. So a natural number is any number greater than 1, aka a counting number, which you use to count natural objects such as birds, trees, etc., and usually living things like animals, etc. So this is numbers that are whole numbers and they're greater than 1. So not including 0 or negative numbers. So numbers you use to count. So 1, 2, 3, etc. So prime numbers are any numbers greater than 1 or natural numbers which can only be divided by itself and the number 1. Example 2, 3, 5, 7, etc. It may or may not be even. It can be odd or even. And the composite number is the opposite of a prime number. So it means it's a number that can be divided by more than just itself and 1. An example is the number 8. So you can divide it by more than just 1 in itself. It's a composite number. And it also has to be a natural number, which is a whole number greater than 1. So that was note 1. The next note is the magnitude of a number is its distance from 0. And the magnitude can be of a positive or a negative number. It's just the distance. So it is basically the absolute value of the number. Example, the magnitude of negative 70 is 70. So the absolute value of negative 70. The magnitude of 21 is 21. So if you're comparing the number negative 70 and the number 21, even though the negative 70 is a smaller number in reality, but the magnitude of negative 70 is actually greater than the magnitude of 21, just because its distance from 0 is greater. So if you're asked the magnitude, negative 70 has a greater magnitude than 21. The next note, when solving equations, you must do all the work in parentheses first. So this is a good hint. So parentheses before anything else when solving equations. The next note, if two lines are exactly parallel, they will never cross. So there is no solution to that system of lines. So a line usually represents an equation. So if you have two equations and they're parallel, that means they don't have a common meeting point. So there's no way to solve that system. There's no solution. And the next note, to change a decimal number to percentage form, multiply by 100. This is easy. So you just add a percentage sign. So 1.9 in percentage form would be 190%. You just add two places to the right of the decimal point. The area of a triangle is base times height at the right angle divided by 2. So if you have a right triangle, base times height, so and divided by 2 would be the area. So the formula for area of a parallelogram is length times height. So length times height. Parallelograms they look like rectangles, but two of the sides are slanted. I guess they're just considering the height at the perpendicular angle. So to find the perimeter of a rectangle, you use the formula just 2 times the length plus 2 times the width. Just like the perimeter of anything else, you're basically adding all the distances of all the sides, just the length in one dimension. The distance D between the points A equals x1, comma y1, and B equals x2, y2, which are two coordinate points that can be found on a coordinate graph, is given by the formula D equals square root of all of the following: x2 minus x1, parentheses cubed or squared, plus y2 minus y1, parentheses squared. So the distance between the points. So say you have 2 points, like 2, 3 and 5, 7. 2 points on a plane with the x and y axis. The way you would find the distance or the length of the line between those 2 points, you use that formula. So the distance is the square root of the difference between the x, the x's, so the first number digits of the 2 coordinates, or so x2 minus x1, and you square that, and then you add the difference of the y's, y2 minus y1 squared. So you square the differences, you add them, and then you take the square root of the whole thing, and that gives you the distance. If you practice it, it's easy. You just have to do it a few times and you'll get the hang of it. I was just double checking with the help of Ruben to Google the area of a parallelogram, because I was thinking, how come length times height would be the same as the area of a rectangle, which the angles are all straight, but or are right angles, but it is the same formula, base times height. And reason being is probably because there's two sides of the parallelogram probably cancel each other out, so they end up being the same as of a rectangle. Okie doke. The next note is the Pythagorean theorem for right angle triangle with legs A and B and a hypotenuse C. The formula you use is a squared plus b squared equals c squared. So if they want you to find like the hypotenuse, which would be the third side or the longest side of that right triangle, say you have 2, 3, and 4 as the lengths, you would go 2 squared plus 3 squared equals 4 squared. Equals c squared, because you wouldn't know this. Okay, it would probably be something more complicated than that, but you wouldn't know, so you'd be solving for c, but you would just do that. You would square the 2 sides and solve for c squared, so you would just get the square root of whatever the sum of a squared plus b squared is, and you would get the length of the hypotenuse, or the longest side.